The F-22 Raptor defined a generation of air dominance, but its replacement is already here, and you haven't seen anything like it. So, what's the replacement, you ask? They call it NGAD, which stands for Next Generation Air Dominance. It's not just a jet. It's a family of systems centered around a sixth-generation fighter that will redefine combat in the skies. This aircraft is designed for total advantage, extreme stealth, adaptive engines, AI copilots, and upgradeable software architecture. It's smart, it's survivable, and it's built for the future. NGAD won't fly alone. It will command autonomous wingmen, drones that scout, jam, and strike, all coordinated by a single pilot. The F-22 was built for yesterday's wars. NGAD is built for tomorrow. It's designed to counter China, survive in denied airspace, and operate with total autonomy. NGAD is more than a fighter. It's the next era of air dominance. NGAD isn't just a successor to the F-22. It's a complete shift in how air superiority is defined. The Air Force learned from 2 decades of stealth operations, global conflicts, and cyber evolution. NGAD is designed not just to dominate in the air, but to do so in a world where every fighter is a sensor, every mission is data-driven, and every target is defended by integrated electronic kill zones. One of the core innovations is modular open architecture. That means NGAD can adapt on the fly, new weapons, new software, new missions, without overhauls or years of downtime. Imagine an aircraft that updates like your smartphone but fights like a predator. That's NGAD's real edge. Then there's the adaptive cycle engine, codenamed XA100 or XA1001. This power plant can shift modes for speed, stealth, or efficiency. Traditional fighters have to pick one. NGAD can shift dynamically. It's like having a sports car, a hybrid, and a stealth vehicle, all in one airframe. Stealth? Next level. Radar-defeating curves, active cooling, internal weapons, and low infrared signature. But NGAD may go further, using AI to actively manage stealth profiles mid-mission, adjusting surfaces or signal output in real time. And the AI isn't just in the sensors. It's in the cockpit, not as a gimmick but as a true co-pilot. This system learns the pilot's habits, recommends flight decisions, and can even take over in high-stress engagements. It's not just manned flight, it's man plus machine. That's why the program isn't just building a jet, it's building a network. Loyal wingman drones will act as extensions of the pilot. Some will carry missiles, others will jam or scout. A few may never come home, but all of them will make the NGAD pilot the most informed, protected operator in the sky. The cost? It's steep. Some reports say over $200 million per aircraft. We may see operational units in the early 2030s, but you can bet the black budget has already moved this further than anyone outside the Pentagon knows. Some speculate NGAD may be optionally unmanned in its final form. Others believe it will carry directed energy weapons. What's clear is that it's not the last jet fighter, but it may be the last crewed air dominance fighter we ever build. NGAD isn't just a military project. It's a collaboration between the U.S. Air Force and some of the most advanced aerospace companies in the world. Leading the charge is Lockheed Martin, but Northrop Grumman and Boeing are also heavily involved in developing variants and subsystems. This isn't a one-contractor jet. It's a modular, competitive program that pulls in the best innovations from across the industry. The propulsion systems are coming from General Electric and Pratt & Whitney, who are both working on next-gen engines under the Adaptive Engine Transition Program, AETP. These engines aren't just powerful, They're smart. They adjust airflow, temperature, and bypass ratios in real time depending on the mission. That gives NGAD more range, more thrust, and more survivability in hot, contested zones. The Air Force has already acknowledged that a demonstrator has flown, possibly as far back as 2020. But what they haven't said is who built it. Some believe Boeing's experimental fighter testbed may have been the first flight article. Others suggest Northrop Grumman's cranked kite design was the basis for the stealth test model. Either way, the test flights are happening now. Behind closed doors, inside the Nellis test and training range and other black sites. And it's not just airframes being tested. The entire NGAD ecosystem, including AI pilot logic, secure data link encryption, and wingman drone coordination, is likely being evaluated using simulations, synthetic environments, and live fly scenarios right now. Let's talk comparisons. NGAD isn't being built in a vacuum. Its biggest rival? China's J-20 Mighty Dragon. The J-20 is a stealth fighter, no doubt. It's large, agile, and has seen rapid upgrades in avionics and radar. But NGAD is expected to leap far ahead in terms of stealth shaping, sensor fusion, and especially integration with drones. The J-20 was designed to match the F-22. NGAD is designed to leapfrog it entirely. Russia's Su-57 Felon is a different story. While it has impressive maneuverability and some stealth characteristics, production is limited and its battlefield reliability is still uncertain. NGAD isn't trying to match these fighters. It's being built to dominate them in detection range, electronic warfare, and first kill capability. The U.S. strategy isn't just to build a better jet. It's to create an air dominant system that sees first, thinks faster, and strikes before an adversary even knows it's been targeted. Future air combat won't be about dogfights. It'll be about information, speed of data, trust in AI, and control of the electromagnetic spectrum. NGAD will act as a flying command node. While the pilot manages high-level decisions, onboard AI will track targets, manage jammers, and even deploy countermeasures autonomously. That's where manned-unmanned teaming comes in. Loyal wingmen drones aren't just sidekicks, they're force multipliers. A pilot in an NGAD could direct a swarm of drones to suppress enemy defenses, conduct ISR missions, or even draw fire away while the manned fighter strikes with precision. These drones won't need constant direction. They'll operate in coordinated swarms using real-time battlefield logic, sharing targeting data across a mesh network. Each one could carry different payloads, from kinetic to electronic, and change roles on the fly. This isn't science fiction. The Air Force has already tested Skyborg, an AI brain for autonomous drones. And programs like DARPA's Code and ACE are laying the foundation for real-time combat learning and adaptation. In the future battle space, the edge won't go to the fastest jet. It'll go to the smartest system. And NGAD is being built to be the mind and the muscle of that system. Some say we'll never see a seventh-generation fighter, because NGAD will already be the last of its kind. Others believe the next leap won't be in speed or stealth, but in autonomy, directed energy weapons, and orbital integration. Think about aircraft that can fire high-energy lasers to disable enemy systems mid-flight, or fighters that act as part of a multi-domain cloud, sharing data not just with jets, but with satellites, submarines, and ground forces in real time. And what happens when AI doesn't just assist, but fully replaces the pilot? That's the direction we're headed. And NGAD is the bridge from the legacy airframes of the past to the battlefield of the future. It's more than just hardware. It's doctrine. It's decision speed. It's who owns the air and the digital space it flows through. VOLOTECH will be watching every evolution, so if you want to stay one step ahead of the next generation of warfighting, subscribe now. We're just getting started.